Ever wonder why you still forget your own passwords while Albert Einstein was casually rewriting the laws of the universe? Einstein's capacity for insight came from a brain physically wired to be different from yours. Welcome to SM Says Psych. Today, we are skipping the complicated science to show exactly why your mind operates differently from a true genius. For decades, it was assumed that a mind capable of constructing entirely new physical realities must be significantly larger than average. If a person holds vastly more information than their peers, it stands to reason they require a larger container to store it. However, the data tells a different story. Albert Einstein's brain weighed exactly 1,230 grams. That number falls slightly below the standard average weight for an adult human male, which typically ranges from 1,300 to 1,400 grams. We know this exact measurement because pathologist Thomas Harvey removed, weighed, and preserved the artifact in a jar within hours of Einstein's death in 1955. These measurements suggest that raw macroscopic volume does not dictate intelligence. Instead, the foundation of genius relies on microscopic structural optimization. When neuroscientists moved past the weight of the brain and analyzed localized cellular variations, they discovered a highly specialized hardware configuration. Einstein's parietal lobe contained a significantly higher ratio of glial cells to sustain intense neural firing. His parietal lobes were wider, and his prefrontal cortex featured a rare fourth gyrus. Connecting these, his corpus callosum was thicker in most subregions, facilitating rapid data transfer. These structural anomalies mean Einstein's prison possessed the specialized cellular machinery to handle the high-energy data integration required for his complex theoretical work. Physical hardware provides the foundation, but the true divergence lies in the functional mechanics of the brain, its operating system. This is modeled by the parieto-frontal integration theory, or PFIT. It suggests intelligence relies on an ultra-efficient superhighway that routes abstracted sensory data from the parietal lobe to the prefrontal cortex for hypothesis testing. While you might expect a brilliant mind to be working in overdrive, brain imaging often shows the opposite. Highly intelligent brains utilize less metabolic energy during standard cognitive tasks. In an average brain, problems trigger diffuse activation, expending wasted energy on task-irrelevant regions. A genius brain utilizes a streamlined approach, activating only specific neural circuits required while inhibiting extraneous activity. When presented with tasks of extreme difficulty, the average brain often reaches its metabolic limit and stops processing. The genius brain, however, scales up its targeted cortical power, marshaling vast reserves to meet the computational demand. By preserving energy during normal tasks, the genius operating system ensures that massive cognitive reserves are available when a problem truly demands them. When an average person looks at complex equations, their working memory must process every variable individually, leading to rapid cognitive overload. A genius bypasses this limit by automating complex principles into single chunks in their long-term memory. The genius advantage in working memory is driven by raw processing speed. Their minds operate at a higher clock speed, continually refreshing data before it naturally decays from their conscious workspace. This speed is paired with a perceptual filter called latent inhibition.
For the average person, this filter blocks out background noise, like irrelevant sights and sounds, to maintain focus on pragmatic tasks. Geniuses often possess low latent inhibition, meaning their pre-attentive filter is porous. Their conscious awareness is continuously flooded with a vast array of sensory and conceptual associations that others unconsciously block. High intelligence acts as a biological buffer for this influx of data. Instead of causing confusion, the genius mind organizes the chaos, facilitating the divergent thinking that allowed Isaac Newton to connect a falling apple to the orbital mechanics of the moon. While the average person relies on high latent inhibition for daily focus, the genius mind functions with a porous filter, continuously identifying hidden patterns within the environmental noise that others never perceive. This constant search for patterns is part of predictive processing. The brain doesn't just see the world, it generates guesses about reality to minimize surprise or prediction errors. Because processing surprise is metabolically expensive, the average brain is often biased toward routine. When it encounters an anomaly that doesn't fit its model, it typically ignores the error to maintain a stable worldview. The genius brain, however, actively prioritizes and hunts for these black swan data points. It functions as an agile, generative model that utilizes anomalies as raw material for new insights. When Einstein realized that the constant speed of light violated classical physics, he didn't ignore the contradiction. He allowed the existing model of space and time to collapse, generating the new predictive hierarchy of special relativity. From this perspective, genius is the capacity to rewrite reality by actively digesting the very errors that the average mind rejects. These neurobiological advantages manifest as highly unconventional behavioral traits in real life. During his isolation at Woolstart Manor, Isaac Newton exhibited extreme hyperfocus. He worked obsessively for days without food or sleep, sustaining an immense cognitive load until he established the foundations of calculus and universal gravitation. Einstein's methodology relied on Gedankenexperimente, or thought experiments. His brain often bypassed verbal language and math in favor of vivid, spatial visualization. At age 16, he imagined what it would look like to run alongside a beam of light. He used raw physical intuition to identify flaws in prevailing theories, long before he translated those insights into mathematical equations. Whether through relentless hyperfocus or visual intuition, these biological advantages allow a mind to move past established rules and generate more accurate models of the physical world. I genuinely cannot thank you enough for making it to the end of this video. From the bottom of my heart, your support means absolutely everything, and it's the only reason this channel exists. Please, I am practically begging you, drop a comment down below. What questions do you have after watching this? What deep psychological mysteries or hidden truths do you want me to uncover next? I read every single comment, and I want to make exactly the videos you request, so please tell me what you want to see. And if you haven't already, please hit that subscribe button and follow the channel. I am pouring my soul into making these amazing videos for you, and your subscribe is the greatest gift you could give to help this channel grow. Thank you again so much. This is SM Says Psych, and I'll catch you in the next one.